polynomial is a function in the form ax to the nth plus bx to the n minus 1 plus bx to the n minus 2. So when our exponents are in descending order, so going from largest to smallest, we have the same variable, x, in all of these cases. That's what we call standard form of a polynomial. So each term is in the form ax to the n. A is coefficient. A specifically is the leading coefficient, and n is the exponent, which we will also discuss. For the leading term is the degree. So that one is your leading term. We have a couple polynomials that we've already dealt with. You're writing this down. Mx plus b, that's your linear polynomial, where we have no exponents. When we have the x squared, that's a quadratic. Thank you. And when we have x to the third, that is a cubic. So similar, you just call it a fourth degree polynomial. So beyond a cubic, I know. So all of these can be written in this form. If we were to multiply out the cubic, similar kind of to what we did in the warm-up, we could write it in this form in standard form with our exponents in descending order and no more parentheses. The following are not polynomials for a number of reasons. None of them can be written in this standard form, but we have the variable is in the exponent for our exponential, so it's not a polynomial. The variable is under the square root sign, so again, not a polynomial. And the variable is in the denominator. So once again, not a polynomial. So the degree of the polynomial is the value of the highest exponent and I'm going to put when everything is multiplied out. So when you're in standard form. So just to kind of give you an idea here, on f of x, that's in standard form. We have our exponents in descending order. There are no parentheses that we have to worry about. G of x is in factored form, so we would have to figure out what our leading term and our highest exponent would be if we multiply that out. And the same thing with h. So what I want you to do is take a moment and discuss with your group what you think the degree is of all three of those, f of x, g of x, and h of x. So the leading term, as I mentioned before, is the first term that has the highest exponent with it. When you're in standard form, highest exponent is going to be your first term. So once you've multiplied everything out, if things need to be multiplied out, the first term is going to be your leading term. So what is the degree on f of x? 5. That's already in standard form. You don't have to multiply anything out. What is the leading term on f of x? 7x to the 5th. What is the degree on g of x? 4, because we would have x times x times x times x if we were to multiply that whole thing out. That doesn't mean we need to multiply the whole thing out. That would be a waste of our time, but we do need to know what the degree is. And what would our leading term be? X to the 4th. Because we have no coefficients with any of those or out front. And what's the degree of h of x?
4.
Also 4. Because we have x plus 5 to the 3rd, which if we were to multiply that part out, we'd have x to the 3rd for our leading term. And if we multiply that by this x, we would have x to the 4th. What would our leading term be? 2x to the 4th. Because of that number right there, we'd end up distributing that 2 when we got all done multiplying the rest of it out. Any questions on any of that? Okay. The last one are types of roots. So we have roots slash x-intercepts. They're the same thing. So wherever it crosses the x-axis, we call that a root. There are way too many phones out right now. So we name them in 3 different ways. A bouncing root is one that comes up or down, touches the x-axis, and changes direction. When it just goes straight through the x-axis, like this one and this one, those are simply crossing roots. And there are more official terms for them that we'll talk about later, but for now, we're just referring to them as bouncing, crossing, and then we have flat. So it's continuing in the same direction, but for a time, it flattens out at the x-axis. So you guys are going to pull up all the... You're going to put in all the different equations. So stop playing with your iPads. Put your eyes on the screen. Up here. Davis, off your phone. All right. So there are a couple things that you're needing to fill out, and I want to clarify what you're filling out. So if you go to the top of your worksheet, you have degree, and then under that, leading term. So if I look at P sub 2, what's my degree of that equation? 3. And what's my leading term going to be? X to the 3rd. Now, on Desmos, when I pulled this up, I had a graph that looks not like what I'm going to graph. So give me a moment. So I'm on the wrong one. So my x-intercepts are at 2 and -5. Comes up from the bottom, bounces at -5, goes down, and then turns back up and crosses through at 2. Just wait. Okay. So this sketch that you are putting on your paper is not concerned about the scale of the y-axis. Because if we look at the actual graph, like if you try to go all the way to the bottom, the lowest point on that dip right there is down at like -52. So we're not concerned about the scale on the y-axis. What we're most concerned about is what's happening at the x-axis, what types of roots we're dealing with, and our end behavior. So my x-intercepts are at -5. And what type of root is that? That is a bouncing root. What's my other x-intercept? And what type of root is that? That's a crossing one. There are 2 ways to look at your start direction and your final direction. The simplest one is the arrows. So my start direction is down, my n direction is up. Vast majority of people prefer to look at it that way. Other people, it makes more sense for them to think about what are happening to the y values. And if I go from left to right, what are happening to my y values here? They are increasing. And then they're decreasing here, and then my n direction, they are increasing again. So, you don't have to, on your worksheet, you don't have to write both of these. So when it comes to your arrows, I'm going to write this off to the side. Or when it comes to your start and your end direction, if you prefer to think about the arrows, specifically use the terms up or down. If you prefer to look at the y values, like what's happening to the y values, then I want you to use the terms increasing or decreasing. It doesn't matter. Whichever makes more sense to you is perfectly fine. Just make sure that you use these particular terms so that I know which one you're talking about. Yeah, as you go left to right, so if you're... So you're looking at your start direction. So as your so think about it this way. As your x values are increasing, your start direction is that your y values are increasing as well.
But you don't have a middle?
No, we're not referring to the middle. Okay. And then the end direction is also increasing.
So they're both increasing? They're both increasing?
Yes.
I told Nick that Nick said that almost decreasing. I said they're both increasing.